Hello, everyone. Thank you for joining us today, and thanks, Google, for arranging such a nice event. Happy to see familiar and new faces. My name is Leonid, and together with Taras, we are going to talk about something SONiC community has been circling around for a while. How lightweight we can get SONiC and still call it SONiC. Most of us know SONiC from hyperscaler deployments, and that's the environment where it was born. Big, even chassis system, powerful CPUs, huge amount of RAM, and plenty of storage. But today, we are going to move into a different direction. SONiC is going to move downward into places which are more constrained. Enterprise access, campus, telco, even industrial networks. And when you bring SONiC into those environments, you suddenly face a very different set of hardware requirements. So let's set the context. In data center, a switch is almost a small server. You might have a Xeon D, 816 gig of RAM, hundreds of gigabytes of flash, and nobody thinks twice about running multiple containers on top of that. But when SONiC lands into access realm, somewhere in the building, maybe powering those Wi-Fi access points or cameras here, the story changes. Now you are looking at something like dual-core ARM, 4 gig of RAM, and a couple of gigs of storage. And usually there is zero redundancy at platform level. At the same time, enterprises still want the benefits of SONiC. Open, consistent, API-driven, and standard model to use network operating system. So the question becomes, how do we make SONiC fit into this hardware without breaking what makes it SONiC? Well, to answer that, we need to remind ourselves what actually defines SONiC, what makes SONiC SONiC. At high level, SONiC is more than just a Linux distribution with some networking daemons. It's a model, it's a way of structuring switch operating system. Few pillars that define that identity: modular, containerized architecture, Debian-based environment, switch abstraction as a common hardware abstraction layer, Redis as a central database to keep operational and runtime data, and finally, all this should run together. APIs, CLI, telemetry, everything has to be aligned. This combination is what operators expect when they hear the word SONiC. And if we go a bit deeper, let's see what are the actual components in this architecture. Looking under the hood, SONiC becomes a collection of building blocks: SAI, Redis, switch state service, org agent, FRR, teamd, and the whole container ecosystem on top runs it. All these pieces together forms the minimal viable SONiC platform. And these are the pieces we have to think carefully about when fitting into much smaller system. Because if you strip away too much, it may run, but it's no longer SONiC in the way the operator understands it. And here is a time where we need to make sacrifices. And I let Raz do his job and give away something.
Yeah, thanks, Leonid. Before talking about giving away something, I'd like to talk more about the role of Docker in SONiC. As we remember from the architecture diagram Leonid was presenting earlier, each and every service in SONiC runs as a separate Docker container. This proved to work for quite some time, and we know that SONiC is quite successful in different areas, and it gives quite a unique experience from the application development point of view. Your service, your application is isolated. You control your own destiny, your dependencies. You don't care about the conflicts. You just need to communicate with SONiC within the SONiC through the Redis database, and you are in self-contained environment. Perfect condition. Choose whatever language you want. Choose whatever the technique you want until you talk with system with the right communication channel, either through database or through the RPC. You can do whatever is best for your current environment. This provides a unique way that we can have the SYNCD as its own container running with its own set of dependencies for different ASIC, ASIC A and ASIC B, that can conflict in the real world. In this case, we've isolated it, having a nice contained manner, and basically we have the possibility to slice the system to the smaller chunks. This is quite unique from the system design. It's been known already for like a microservice architecture, and we've seen this kind of systems. So this proved to work. It comes with the price. The price, and I believe I was asking this question several times to all the speakers, how much memory, what would be the footprint? And here I've already, this is basically the reuse of my previous talk, of this diagram. This is the snapshot of the virtual SONiC running the T0 config without any traffic. So it just booted, and it's a snapshot of the processes. As you can see on the left side, so-called supervisor group, container CFG group, supervisor X, process X, exit listener, container wait. So this is the part of the infra that is checking and making the system to stick together, and it's consumed up to the 40% of all memory in runtime when you just start without any configuration. And rest on the right side, as you can see, there is some services, Docker, REST server, RSS log, Redis. It's much smaller. You cannot even see it clearly. And this is okay for these kind of platforms, because we are talking that the ASIC itself and the optics and the power supplies, they are much more expensive than the CPU, and you can easily drop. I don't know if the Xeon currently not enough, you can take a new Xeon and put even 2 Xeons. No one does it, but you understand my thought process here. The CPU and memory of the overall BOM of that kind of platforms is negligible. And typical SONiC current SONiC platform, we have Xeon class CPU, we have 16 or maybe even 32 gigabyte of memory. We have a fast SSD and NVMe storage, and from the port density perspective, we have a 800 gig. Now, this year, we've seen all the announcements of 1.6 teraports. So SONiC works great there, but it's not just these platforms. This is what we typically see on the access management and campus networks. This is plain old boring 1 gig, maybe multi-gig switches. Maybe, it's definitely not for the AI. No one runs AI networks through the switches, but there are still several orders of magnitude more of these switches than the previous one I was showing. And the biggest difference between the data center switches and this kind of access management is the BOM price is super sensitive. You're not deploying for each one switch deployed in data center for the AI training, we are deploying thousands of tens of thousands like this all over the world. And the footprint of those is completely different. We are typically running either low-end x86 or ARM. We typically have up to maybe max 8 is super unusual gigabyte of RAM, and we have 8 gigabyte of storage on the switch itself, and this is treated as the quite powerful access switch. We've seen even like megabytes of storage and megabytes of RAM even sold now. So how we can run SONiC on those? As Leonid was saying, we started to think what needs to be sacrificed and what needs to be done in order to put the SONiC on it. And coming from the embedded world, previously in my previous life, we worked with the team and realized, okay, let's take the baseline embedded Linux. Let's put all the SONiC services, the same services we're talking about, that was running in the Docker, put them natively on the system. Same Redis, same switch state service, same FRR, same DHCP relay. We minimized all the dependencies from the Python infra, that process listeners, feature D, all the stuff that makes SONiC a bit. We've moved it all to the systemd based startup sequence, and it's just the processes on the system. And
we've seen quite a reduction. All that left part from the diagram I was showing on the previous slide is now gone. So we've seen a huge decrease of the memory usage, and also we've seen a quite a improvement of the overall system responsiveness. And I will show some details later on. But we still used the vendor SAI, so we still use the SYNCD, we still use the ORC agents, switch, BGPD, FPM SYNCD, all the parts are still running there. But the price is a bit, I would say, controversial. The first thing that we've lost while doing this is the wormwood. It's not that we did it intentionally, it's just because all that infra that we are saying it's heavy and nasty and all in Python, it's there not because the people in SONiC community cannot write the code. They can, and they do really good. But there are so many corner cases, especially in the wormwood and fastboot, where we need to place in the system to support it. So by removing all of this, the first thing we got this was the wormwood. We will be working to add it, but I'm afraid that once we will have all the corner cases, we might be in the same position that the current SONiC is, unless we will find out different solutions. We also lose the possibility of the per component upgrade. So in SONiC, you can stop the Docker, update the image, start it again, and you have a new version. There is even SONiC app extension framework, which allows you to download external containers and you magically have the image. We've lost it as well. We've also reduced the flexibility. Currently, the version of it is basically like a firmware to the router. I believe at least some of you will ever try to update the router. You have one file, you put it, it just works. You have almost zero flexibility there. And also, we lose a bit of the ecosystem because people that works with SONiC know it's Debian, it's the make build system. And if you can log into the system and you need some tool, you can do apt-get install. With the embedded flavor of Linux, it's not happening. But this is what we gain. And I try to put some, let's say, some more extreme comparison. Some of the things works exactly the same, but we took the really, really low end from the CPU perspective platform. We had 2 ARM cores, and we had 4 gig of RAM and 8 gig of eMMC. So not the fastest CPU, not the fastest RAM, and not the fastest storage available currently in the market. And we were measuring on the same exact platform 2 versions. We were measuring the 2024-5 SONiC image built from community, and we were measuring bare metal SONiC. The first thing is, how long does it take once you start the switch so the first packet can be sent through the switch? On the 2024-5, we've seen like 11 minutes. I don't know if it's good enough or not, but at least for me, it's outrageous. It's even worse when you want to reboot. It takes time to shut down the system, and it takes time to start it up. It's 14 minutes. But I believe what users are mainly frustrated, might be frustrated on this kind of the environments, is the responsiveness of the system. When you type the show interface status in the console, you should wait at least 10 seconds to see any output. So this system is literally unusable. But when we take a look on the embedded version of this, we've seen that the time until the first packet is being sent through the switch is down from 11 minutes to 80 seconds. So it's basically 10 times less. When the reboot time is instead of 14 minutes, it's 2 minutes. The interface output is instead of 13 seconds, we are talking 1.5 seconds. But I believe the biggest win we've seen here is the image installer size. When you get the SONiC when you download SONiC from the Azure pipelines, it's about gigabyte, sometimes less, sometimes more, but around this size. Here we are talking 150 meg, assuming that, and sorry for the chip vendors here, I believe like 40 megabytes of this size is the SAI package from the vendor. So if we can squeeze it more, we can be even less on the size. So as a summary, what I want to hear and what I want to, let's say, to report to community and get some feedback from community. By having the control plane from SONiC repackaged and reshaped on for the different environment, but still being the same control plane and still utilizing the same node-bound APIs, can it be called SONiC? My answer is yes, but it's community to decide what would be the proper size. And most important question I believe I want to ask here, we see that SONiC is growing to new areas and new use cases through all of the networking domain. We see the AI data centers, we see the scale out, scale across. Interesting one is scale up. You don't need all of the components in the scale up. Maybe this can be here. I don't know. I'm trying to put some AI to my presentation because without it, presentation doesn't make any sense nowadays. So I need to put something. But yeah, so we see a new use cases. We see a new markets that are evolving and want to use SONiC, and we believe that by allowing this flexibility to repackage the control plane, which is going to be stable, which has been developed and tested by the number of companies and it's heavily deployed to fit a new use cases. And I believe this a bit correlates with the presentation that Google was saying that let's also change the complete build system and just build the pieces we want. Yeah, maybe we should talk with them how we can utilize this as well. And we're ready to take the questions.
Thank you so much for doing that. I kind of had a name in mind, hypersonic. We've actually talked about it internally a little bit. So now I saw on the last slide, you did mention things about C groups, but you also previously mentioned what that process being able to interfere with others. You can do that isolation of C groups. You can limit memory, CPU usage, all that stuff. Is that something that you've already implemented with your testing?
So to be honest with you, and we see that there is no need to the so tight isolation that Docker provides that you can have complete, let's say, your own environment to each and every process. And up to the, I believe, previous release, all the processes, all the Docker containers in SONiC were running in the same network namespace. So it was just, I mean, we didn't find anything that prevented us to run and the conflicts. Can we implement some kind of isolation? You're right, C group is for the resource limiting. Can we do some isolations? Yes, we can, maybe with up armor or something, but there was no need. We didn't see that something was broken. There was a lot of magic we need to do, and you know I mean, I was talking to my team. Why do this? Why do this? Why do that? And everyone is saying it's just a magic, you know. But we can talk separately about it.
And then the other question was another big NOS vendor out there that's based on Debian as well, just provides a repository that you can do updates from. Is that in scope for what you're potentially looking at?
No. Again, if we go to the Yocto base, we can do the package streams. Not a big deal here. But the whole idea is keep it as tight, as simple as possible. We are losing a lot of flexibility that Debian provides us and a lot of stability that Debian provides us, but we are gaining a lot of the build time, build reproducibility, and the consistency of the image itself. Yes, it's a lot on the vendor side now to prepare this, but once it is done, it's just much more stable and controllable by the vendor itself.
Okay, thank you.
I was just wondering, did you have to make any changes to the individual components, the SWSS, LODP, BGP?
Mainly build related and flags related, but the logic itself was not changed at all. I mean, some sockets passes, but nothing that relates to the functionality itself.
And were you looking at getting those changes pushed upstream?
That's an interesting question. We still need to work with the community to understand, because this change is basically the removing the build image repo and creating a new one. But I don't believe that the community will allow me to remove build image repo. So I believe they'll need much more discussions.
Yeah, that's a good question. How to introduce flavors of SONiC?
Yes, how to do the flavoring. I was always repeating that we need to introduce new flavoring, how we package it. We did it on the extreme basically inside the company, because we could allow ourselves not to take the build the image repo. How to put it the community? It's a really tough question.
I have some suggestions on build systems, but they're probably equally unpopular.
Thanks, PL Vision team. One more question here. This is Ishwaran from Nextdoor. So follow up from that question over there. So which is, suppose we can add this flavor to SONiC build image or somewhere where you can actually make this happen. How bad do you think the sync will be? Like if you maintaining stuff internally, are you even syncing anything from upstream now at this point? Is it?
So I believe I can. So how the current build system works, there is a file with the hash commits of each and every SONiC repo, and the system just grabs it and builds it. This is how we done it internally. So that's why I said I would need to remove SONiC build image or introduce something new. Again, this is a really good question. I believe it requires more in-depth technical discussion because we cannot just replace what SONiC is now. There are a lot of reliance on it in different use cases, not just campus. So by introducing campus, we shouldn't break other use cases.
Okay, got it. Thank you. And to answer your question, I think this is still SONiC. Thanks.